Welcome to our CCS department network. In this video, we will present how we design and build a complete network system using Cisco Packet Tracer. Our goal is to create a functional and organized network that connects three main areas: the CCS office, the CCS student room, and the CCS visitors room. First, let's look at the logical design of our network. Here we can see that each area is connected through routers and switches. The CCS office contains the main server, workstation, and laptops. The student room is connected to the multiple computers for laboratory uses, while the visitors room provides network access for guests. Through proper cabling and network devices, all three networks can communicate with each other. Now let's move to the physical layout. We arrange our network across a map to simulate a real-world environment. Each building is placed in a separate location: the CCS office building, the student room, and the visitors room. They are connected using network links to show how data travels from one place to another. Inside each building, we organize the rooms and device placement. This includes routers, switches, and computers and laptops. By doing this, we can visualize how network would look if, if it is existed in an actual school campus. We also use correct cable types, proper IP addressing, and logical pathways to make sure communication is stable and efficient. Every device was configured to allow data sharing, internet access, and smooth connectivity.
So first, I configure the gigabit internet 0/0 interface, and I use IP address for that is 192.168.11.1 with a subnet mask of 255.255.255.0. This make the router default gateway for all the devices in the 192.168.10.0 network. I also enable the interface using the nor shutdown command, and the next step I set up is the DHCP service. I create a DHCP pool name of CSS server which automatically assign for IP addresses to devices in ALAN. The pool include the network address, the default router, and the DNS server which is 8.8.8.8. I also exclude the router own IP address from the pool so it won't be assigned to clients. For the WAN connection, router 1 uses a two serial interfaces. The serial 0/1.0 has IP addresses 192.168.9.1, and the serial 0/1/1 uses 192.168.10.1. This point-to-point link allow the router 1 to connect to the other router in the topology. Both serial interfaces are also enabled with no shutdown. To allow dynamic routing, I configure the EIGRP, which automatic system number 1. I added the network also the 912.168.11.0 and 192.168.0 and 192.168.10.0 to the ERGRP process. This allows the router 1 to exchange routing information with its neighborhoods. The no auto summary command ensure more accurate route advertisement.
The configuration begins by entering privileged execution mode using the enable command so that the advanced settings can be accessed. After that, the configure terminal command is used to enter global configuration mode, which allows the administrator to make changes to the router's overall settings. The host name is then changed to CCS Lab Router to easily identify this router within the network. Next, the router's Gigabit Ethernet 0/0 interface is configured, which serves as the LAN connection for devices inside the CCS student room. An IP address of 192.168.12.1 with a subnet mask of 255.255.255.0 is assigned to this interface to define its network range. The interface is activated with the no shutdown command because Cisco interfaces are disabled by default. After finishing the LAN configuration, the settings move on to the serial 0/1/0 interface, which functions as the one connection that links the router to another network or another router. This interface is given an IP address of 192.168.9.2 with a subnet mask of 255.255.255.252, which is typically used for point-to-point connections. The no shutdown command is also applied here to ensure the serial interface becomes active. With both interfaces enabled and assigned to proper IP addresses, the router is now ready to communicate with both local network and external networks.
In this setup, the CCS visitors router is prepared by assigning a host name and configuring its LAN and WAN interface. The first step involves entering privilege and global configuration modes and settings the host name to visitors router. This helps to identify the device on the network, especially when multiple routers are used in large system. Next, the Gigabit Internet 0/0 interface is configured to serve as a local area network connection. The router is given the IP address 192.168.13.1 with the subnet mask of 255.255.255.0, which allows it to act as default gateway for device in local network. Activating the interface with no shutdown command ensure that it becomes operational and ready to forward data within the LAN. The serials the serial 0/1/1 interface is then configured to handle the wide area network connection. This interface is assigned the IP address 192.168.10.2 with the 255.255.255.252 subnet mask, a common setting for point-to-point links between routers. The no shutdown command is again used to activate the interface so that it can communicate with external networks or other networks. Overall, this configuration allowed the CCS router to function properly by connecting internal devices through the LAN and providing communication to external networks through the WAN. Setting up the hostname and interface ensure organized management, efficient data routing, and reliable network foundation for users.
For the connectivity test, I type the command ping 192.168.11.7 in the command prompt to check if my device could communicate with another host in the network. The result showed four successful replies, meaning the connection between the two devices is working. The response times range from less than 1 ms to up to 21 ms, with an average of 5 ms, showing that data is transmitted without any packet loss. The statics also confirm 4 packets sent and 4 received, resulting in 0% loss, which indicates stable and reliable communication. Overall, the ping test proves that the devices are properly connected and able to exchange data within the network. For this test, I used the tracer command to trace the route going to 169.254.145.234 and to see how data travels through the network. The output shows multiple hubs passing through 192.168.12.1, which means the packets are being routed through the same gateway repeatedly. However, some hubs returned request timeout, indicating that certain points in the path did not respond or may be unreachable. This shows that even though the router is responding, the destination address cannot be fully reached. Based on the trace route result, the network is active but the final IP might be unreachable or outside the current network configuration.